Good morning, everyone, and welcome to the July edition of the Southeast Climate Monthly webinar. I am Sandra Rain, the Regional Climatologist from the Southeast Regional Climate Center, and I'll be giving a climate overview for the month of June. We are fortunate today to have two guest speakers, Jeff Dober from the Southeast River Forecast Center, who will provide a water resources overview, and Chip Conrad from the Southeast Regional Climate Center, who will be talking about heat vulnerability. We thank them both for joining us. Just a reminder before we begin that if you have any questions at any time, to please type them into the question box and they will be answered at the end. All right, so let's begin with June. Temperatures were about near average across much of the Southeast for the month of June, with above average temperatures across much of the state of Florida. Only about a handful of long-term stations ranked within their top 5 warmest Junes on record, including Tampa, Florida, which has had its 3rd warmest June. The cooler weather was due in part to a cutoff low pressure system in the middle of June. It slowly moved across the Carolinas and it provided many record low maximum daily temperatures, as much of the area saw daytime highs only in the mid-60s. The warm air pushed up and around the low and into New England. As a matter of fact, parts of New England saw more 90-degree days than parts of the South, with Burlington, Vermont having seen 9 days, whereas Greensboro, North Carolina has had 0 days for the entire month. Greensboro, North Carolina actually saw its first 90-degree day for the year on July 3rd. The Caribbean was above average in regards of temperatures for the month of June, with some stations reporting about 3 degrees above average. St. Croix in the U.S. Virgin Islands has had its warmest June on record, whereas Guyana, Puerto Rico has had its 2nd warmest June. Precipitation varied across the Southeast region, which is common for the summertime months, with wettest locations in Southern Virginia, Eastern North Carolina, and Northern Florida. The driest locations were across much of Georgia and South Carolina. Only 6 long-term stations observed June precipitation that ranked within their top 5 wettest, including Pulaski, Virginia, which received over 11 inches of rain, and that's about 8 inches above normal, making this their wettest June on record. It was drier in the Caribbean, however, especially eastern Puerto Rico. Roosevelt Roads only observed 0.9 inches of rain, making this the 5th driest June for them on record. Although an average number of total severe weather reports occurred this June, the Storm Prediction Center indicated that the United States has had its fewest number of tornado watches for June in recorded history, and preliminary reports of the fewest number of June tornadoes since 1952. The Southeast was also below average for June, with only 6 confirmed tornadoes. That's about half the monthly average of 12. However, there was a notable EF1 tornado that occurred on June 24th in Mobile County, Alabama, with winds of about 110 miles per hour. Fortunately, no injuries or fatalities were reported. On June 6th, damaging straight-line winds impacted the Daytona Beach Flea and Farmers Market, sending debris onto portions of I-95, causing the roadway to be closed for several hours. No injuries were reported with this as well. And there was more hail in Seminole County, Florida, golf ball sized, on June 24th. We didn't see very many tropical systems in June, but we did have Tropical Storm Cristobal. It was the earliest named sea storm since Tropical Storm Colin in 2005, and it impacted the Southeast region from about June 6th to June 8th, providing beneficial rain to Florida Panhandle and southern Alabama. As a matter of fact, Mobile, Alabama received over 6 inches from the storm. We didn't see very much tropical activity due in part to the Saharan Air Layer. It had moved across the Atlantic in the middle of June, suppressing tropical activity. Puerto Rico was particularly impacted, reporting very hazy conditions and the poorest air quality they've seen in 15 years. The current drought monitor is showing no drought for most of the southeast, except in Puerto Rico, where we have severe drought on the southern portions and eastern portions of the country. Over the month, we can see that we started out with some drought in southern Alabama and the Florida Panhandle, but Tropical Storm Cristobal eased that quite a bit. By the end of the month, Puerto Rico, with its dry conditions, sees severe drought in the southern areas. As far as an ENSO update, well, we're seeing ENSO neutral conditions still favored for the summer. However, we are under a La Niña watch, with a 55% chance of La Niña developing for the autumn and continuing into the winter months. As we look at our summer outlooks, there's no drought expected for the southeast, and drought improvement is likely for Puerto Rico. Of course, this depends upon the tropical activity. Temperatures are expected to be above average for July, August, and September, as well as precipitation should be above average as well. As we look at the first half of July, it has been warm, with Washington, D.C. currently seeing 18 consecutive days of 90 degrees or above. This, if they see 22 consecutive days, it will beat its record of 21 days. And this is very likely considering the next few days ahead. Precipitation is a little bit more variable, but we have had two tropical systems so far for the month of July. Edward on July 6th, which is the earliest named E storm for the Atlantic, and Faye on July 9th, which was also the earliest named F storm. So just to kind of give a brief summary, for June, it was cooler in the north and warmer in the south. We saw below average precipitation for Georgia, South Carolina, and Puerto Rico, and above average precipitation for western Alabama and northeastern Florida. The Caribbean June saw above average temperatures with below average precipitation. Notable storms included the Saharan Air Layer, damaging winds in Daytona Beach, Florida, an EF1 tornado in Alabama, and Tropical Storm Cristobal. Current area of drought is in Puerto Rico. Hopefully it will be eased up though. ENSO neutral is favored still for the summer, but a La Niña watch has been put ahead for autumn. And the summer continues to be warm and wet, with hopefully drought improvement in Puerto Rico. And the rest of the southeast, well, we'll see if it remains drought free. It really depends on our tropical activity. All right, now I'm going to send it over to Jeff for the Southeast Water Resources overview.
Okay, thank you, Sandra. Well, here's the latest as far as stream flows across the Southeast. This as of July 12th. You can see on the left side here, we've got the stream flow locations and their current rankings, and most of the Southeast right now running around normal stream flow conditions. The exception mainly across upstate South Carolina, most of North Carolina, and then the southern Virginia, as well as a little pocket down there in the Florida Panhandle in the Suwannee River Basin. Now, how have the trends been? You can see after a very wet late last winter, there, looking at the graph on the right side, we've come down from those very wet conditions, and we've had intermittent wet conditions, but stream flows overall across the Southeast running still much above normal, but now running in the above normal range, much above normal through most of the spring. But now as we head into the summer months, we're closing in on normal so far for the Southeast. That's the 28-day average stream flows. If we look at the next slide, as we look at each individual state ranking, we see Alabama, Georgia, and Florida running in the normal range right now. And those stream flow conditions have come down off their peaks that we've had back in the early spring, the wet conditions in early spring. And really after a wet spring, especially a very wet April in the Carolinas, June was a little bit more normal. But for the Carolinas, they have a little bit of different picture. You can see North Carolina and South Carolina both coming down from their peaks in March and April, but still above normal for both of those states right now as far as stream flows. As far as the next slide, our current river flood status for July 13th, we're not looking at any flooding across the southeast right now, which is not which is fairly typical. We've got a few locations running close to flood or at high flows right now. Those are in the coastal plain of South Carolina and North Carolina on the lower reaches of some of those larger rivers like the Roanoke and the Savannah, where we've seen high stream flows and high reservoirs for most of the spring, and that water is just making its way slowly downstream. We go to the next slide here, and as I pointed out, the not having much flooding this time of year and having it being typical, you can see here we're in week 29 as far as flooding. This is sort of our lull period for most of the southeast. And then as we go into the next several weeks, as we get into the tropical system or season, we see that activity increase. Now this encompasses the whole southeast. As we go to the next slide here, we can see most of the southeast has a lull, but when we talk about the Florida Peninsula or the Florida forecast points, and in particular the Florida Peninsula, we tend to see flooding, especially around the Tampa area, pick up this time of year with the wet season. But as Sandra pointed out, they've been pretty dry and warm down there as we head in the late spring and early summer, and we haven't seen the typical rains that they see down there to maybe start getting some of that flooding going. The other contribution to this, of course, is the tropical season. And so far, they've been able to avoid tropical systems so far this season. Going on to the next slide, as Sandra pointed out, really little to no drought, and we're really not expecting much drought development as we head into the summer, which has been really good. So overall, our southeast stream flow forecast and our sort of inherent flood risk right now, if we look at the southeast, we're near normal across the Florida Peninsula and Georgia and Alabama. But as Sandra pointed out, we're looking at potentially above normal chances of higher rainfall across the Carolinas and parts of the southeast. But with the Carolinas being right now a little bit on the high side, they are a little bit of vulnerable if we do get a tropical system for flooding and high stream flows. And that's why we've got that above normal ranking right now as we go from August, September, and October. So in summary, stream flow is above normal across parts of the Carolinas and Southern Virginia, as well as the Suwannee River Basin and the Florida Panhandle. And this is really typically our low flow period for the southeast, except the Florida Peninsula, and which is typical. But really, we haven't seen much down there in the Florida Peninsula so far yet, and that's why we really don't have much flooding going on in the southeast currently. And then our stream flow forecast for late summer and really in the autumn now is above normal for the Carolinas and near normal elsewhere, and with little to no drought expected into the autumn. So that's a water rundown. And we'll go ahead and pass it on to Chip, talking about heat vulnerability.
Okay, thank you very much. So I'm going to take a few minutes here today to talk about a concern we've always had in the Southeast, and a concern, that's getting a lot greater as the climate is warming up. And then I'm going to share a tool that we've developed at the Southeast Regional Climate Center that predicts heat vulnerability. Next. And so first off, I'm going to start off and just share here this slide. This is from research that we developed a number of years ago, and it's a rather complex slide, but what it shows there is that a majority of the cases of heat illness in the state of North Carolina actually occur during days in which the National Weather Service has not issued a heat advisory or an excessive heat warning. And so just typical days in the summer, there's some people in our population, obviously, that are very exposed, outdoor workers and so forth. And we've come to realize in the research that we've done at the Southeast Regional Climate Center that there are real variations in heat, basically in heat stress. And so we're all familiar with the heat index, which takes into account temperature and humidity, but there's other factors as well. Next. And so, as I mentioned, heat index is used by the National Weather Service, but there's other variables that really play a role here. And so in this slide here, I point out that the heat index takes into account temperature and humidity, but there's something called wet bulb globe temperature that some of you may have heard about, that in addition to those two variables, takes into account wind speed and solar radiation. And so, of course, when the wind blows faster, we get more ventilation, and so we get more heat dissipation off our skin surface. And obviously, being in the sun, or when the sun is really bright, when it's high in the sky, we're being exposed to a lot more energy. And so wet bulb globe temperature takes into account all those factors. Next. And so it was created by the military back in the 1950s. They had a lot of concern, especially around basic training. And a lot of that training was done at bases in the Southeast. And so they basically developed this, and without going into the technical details, I'll just share that they developed a wet bulb globe thermometer, and these are in use quite a bit these days, although we have instrumentation today that doesn't work exactly like what I'm showing you here. But the wet bulb globe temperature is weighted a lot around something called natural wet bulb temperature, about a 70% weighting. And that basically takes into account humidity and to some extent wind speed and radiation. There's also a globe temperature, and you can see the device there, the picture there in the upper right. You see the black bulb there, so that just absorbs radiation. There's a thermometer on the inside, and so obviously as more radiation strikes that really dark surface, the warmer it gets. Then added to that also is simply the dry bulb temperature, which is what we think of as the regular temperature. So those are weighted differently, but that comes up with a very good estimate of wet bulb globe temperature. Next. Okay, and so increasingly high schools across the country are developing guidelines around practice, whether you can practice or not, or whether you can be in full pads or not, how frequently you take rests and water breaks, and it's all dependent upon wet bulb globe temperature. And so a lot of these high schools actually have devices that estimate it, and so they'll put the device right next to the practice field and they will measure it. And so the high school athletic associations in various states have mandates here. And so the wet bulb globe temperature, it scales a bit different than what we would think of, in terms of regular temperature. So if, for example, if the wet bulb globe temperature is over 90 degrees, that's really dangerous, okay? And so when that's measured by a practice field, they're not allowed to practice at all, at least in North Carolina. And you see as you get lower values, there's things that they have to do, but it's not so strict. And then when you have basically values below 85, conditions are okay, and you just basically need to do monitoring. Next slide. So in the research that we've done at the Southeast Regional Climate Center, we found out that wet bulb globe temperature is incredibly sensitive to wind speed. And I'm going to be emphasizing this here in a second, but this graphic here basically shows for different types of days here in terms of cloud cover. And if you look at the red line, this is for a sunny day, a typical day, let's say in the late summer, August or September. Temperature is 86, the dew point is 70. But what it shows there is that if the wind speed is blowing 3 miles an hour, which is a slight breeze, you're only in the yellow flag. It's not too bad. That's about 80, according to the scale, 88 degrees. But if you reduce the wind speed down just 2 miles an hour, down to 1 mile an hour, then it goes very much into the black flag. And so you end up with a value around 94 degrees. And so that's a 2 flag increase in wet bulb globe temperature with just a modest 2-degree decrease in the wind speed. Next. So what we're going to do now is I'm going to show you very briefly the patterns of heat that we see, or the factors that play into heat, and how they vary across the southeast, and how all that plays into how wet bulb globe temperature varies across our region. Next. Okay, so the first slide here just shows temperatures across the region. This is average temperatures in what we think of as the late morning hours going to around slightly afternoon, so 10 a.m. to 1 p.m. And that actually should be Eastern Daylight Time there. And then we see there on the right panel a map for 2 to 6 p.m. Eastern Daylight Time. And the patterns here, I mean, if you're a meteorologist, this looks very familiar, but I want to point out a few interesting things. We know, generally speaking, the farther south you go, the warmer it is when you average it out. We don't quite see that here. We see that the very warmest temperatures are observed basically in the interior regions towards the south. So basically central South Carolina through South Georgia, South Alabama, much of Mississippi. And we see that Florida, by and large, is slightly cooler than areas to the north. And the other thing I'll point out is that near the bodies of water, the Atlantic Ocean, the Gulf, temperatures are a bit lower, right? And so we go to the beach and it's a little bit cooler there. And so temperatures decrease basically right around the coast. Next slide. Okay, dew point temperature provides a measure of how much water vapor is in the atmosphere. And this just generally shows that near and on bodies of water, the dew point temperature is higher. And so going to the south and going over the Atlantic and the Gulf of Mexico, we see higher values. We see the lowest values up in the mountains. So they're up at a higher elevation. Of course, they're farther to the north, but the atmosphere dries out considerably as we go up the atmospheric column. Next. Okay, and so this is a rather, shows a complex pattern, but it shows the average cloud cover in the morning and the afternoon hours here. And we'll just look here in terms of the afternoon. And what's interesting is that right along the coastline there, you see kind of darker blues there. And so it is basically more sunny. And so if you live along the coast, you notice that along the coast itself and out in the water, oftentimes there's very few clouds. That's connected with the sea breeze circulation, but that keeps it, that's one factor that keeps it a bit warmer because the sun stays out while you go inland and you've got cumulus clouds popping up and it's a bit cooler. And we see too, when we get into the mountain areas, particularly in the afternoon, it tends to be much cloudier. You get a lot of pop-up thunder showers and so forth, and there's a lot of clouds that are left over from that. Next slide. And so remember, I was talking about wet bulb globe temperature, wind speed plays a huge role here. And so this shows mean wind speeds in the late morning hours, and then again over on the right there in the mid to late afternoon. And just focusing on that there, we see an interesting pattern where along the coast and off the coast, wind speeds are much, much higher. And so that's due to the fact, of course, we have the sea breeze right along the coast, but also the winds are blowing onshore and there's nothing to slow the winds down. So there's no friction basically. And so the winds blow much faster. And so that provides a real marked cooling effect in terms of the body. So heat can be much more readily carried away by the body. And we see the lowest wind speeds in the interior areas, particularly in the southern Appalachians and parts of the Piedmont of the Carolinas and Virginia, going down into Georgia. And there's an interesting area where you see that wind speeds are higher that are in the coastal plain areas. So you see basically Norfolk there in Tidewater, Virginia, south of Raleigh, Columbia to the south. That broad area there, the winds blow faster because the landscape is more open. There's lots of farms. And so the winds blow faster there, and so that provides a bit of a cooling effect. Next slide. So anyway, if we put all this together, then again, all those factors play into the wet bulb globe temperature. We find here that in the late morning to early afternoon, wet bulb globe temperatures are the highest. So looking at the panel there on the left, and we see that they're highest in basically a region extending from southeast North Carolina interior, so a little bit northwest of Wilmington, and in the interior South Carolina, just inland, so just west of Charleston, going in towards Savannah. And then there, just right along and inside the coast there, all of Florida, and then basically the coastal areas of the western panhandle of Florida, southern Alabama, and Mississippi. And we see a similar pattern in the afternoon. Interestingly, on average, the values are a little bit less, and that's owing to the effect of afternoon convection. So clouds pop up more, and areas get cooling thunder showers and so forth. And so averaged out with more clouds, and at least on those days when it rains and so forth, you get some cooling effect that makes wet bulb globe temperatures a bit lower. Next slide. Okay, and so this just shows the seasonal maximum wet bulb globe temperature. So the sort of the greatest values you would see averaged out over the morning and the afternoon across the region. And I'm just going to point out, because we're short on time, and looking at the right panel there. So they're basically greatest in the mid to late afternoon, and they're the very greatest basically in southern Alabama and southern Mississippi, the interior areas, so away from the coast there. And so those are areas where the humidity can be especially high because they're close to the Gulf of Mexico, days in which there's very little wind speed and temperatures that are really high. So greater there than just about anywhere else. In contrast, in the mountains and beside the mountains there in the mountain valleys, wet bulb globe temperatures, the greatest values tend to be much, much lower. And so relatively few days that are threatening in those areas. Next. Okay, and I think in the interest of time, we're just going to go on here to the last part of my presentation. And so I just want to point out that these are general patterns, but there's tremendous amount of variability in wet bulb globe temperature. We've been doing work at high schools across North Carolina, particularly in the Triangle area. And I wanted to point out a real interesting place. This is a Google map here showing the campus of Cedar Ridge High School in Hillsborough. You can see I-40, it's interchanged with I-85 over on the far left there. But anyway, that practice field, you can't appreciate it from this perspective, but it's down in a low-lying location, and there's almost no wind there. And even on days where you get a decent breeze in summertime, there is no wind there. To add insult to injury, there are wet areas or wetlands when it's rainy on two sides of the field, so we find the humidity is a bit greater there. It's open enough so that most of the day they're getting plenty of sunlight, so lots of sunlight, little wind, and slightly higher humidities. And the consequence of that is that wet bulb globe temperatures are exceedingly high. And so there have been measurements as high as the upper 90s, even close to 100 there. So this points out that there are what we call microclimates, local areas where wet bulb globe temperature can be exceedingly high. And so while you may not be in one of those climatologically favorable areas where you see a lot of high wet bulb globe temperatures, there are little pockets, even far up to the north, where it can be very high. Next. Okay, so very quickly, and just the last 2 minutes I have here, I'm going to show you very briefly a tool that we've developed at the Southeast Regional Climate Center. And this is a collaboration with the Carolinas Integrated Science and Assessments Program, CISA, and also the North Carolina State Climate Office, which is in NC State. But we have this tool that translates National Weather Service forecasts of temperature, humidity, wind speed, and cloud cover into wet bulb globe temperature. Next. And so this tool, it's currently operational in Virginia and North Carolina, but we're going to have a new version available here very soon, and we'll send out an email when it is available that covers the entire region. So basically, the tool is very simple. You find your location on the Google map, you can click on the map and get it, or if you're not geographically inclined, you can go up to the white box there and just type in a location. We've had athletic directors across the state use it. And so they don't know where they are exactly, but they just pop up the name of their high school up in that white box and then basically hit the submit button. And then you get a forecast that you see down there at the bottom. Next slide. And so this just basically blows up that forecast, but it shows for the next 5 days, hourly values going out for the first 36 hours of the predictions of wet bulb globe temperature. And so you can see the ebb and flow with the highs reached typically in the early afternoon and the lows reached early in the morning there. And so, and behind it then is basically color coding that indicates the flag levels. And so obviously where it gets to black, that's where it's highly dangerous. So this is a forecast that we developed twice a day. And again, we're gonna have this available across the entire region here, hopefully very soon. Next slide. So just a few quick takeaways here. So WBGT is increasingly being used to assess level of heat stress, especially in athletics. It's typically greatest inland of the coast from southeast North Carolina through Florida and westward to southern Alabama and Mississippi. And it's those areas, interior southern Alabama, Mississippi, where you can get the highest values over the summer, very dangerous values. WBGT shows much local variation, however, with the highest values found in low-lying sheltered locations that are in the sunlight. So again, the web-based 5-day forecast tool can be found there at the following link. Again, we hope to have it available across the broader region here very soon. Thank you very much.
Hi, my name is Meredith Muth, and I work with the National Integrated Drought Information System, and I'll be here to moderate the question and answer period. First, I'd like to remind people, if you have any questions, please put them in the question box. We do have a few already lined up. We also have a few extra experts on hand from across the region to answer questions regarding regional climate as well as heat issues as discussed today. A link to this recording will be sent out by tomorrow, along with a recap email that you are welcome to share with your networks and colleagues that will summarize key points and key takeaways from today's webinar. This is a monthly webinar series jointly produced and organized by NOAA, National Weather Service, the National Integrated Drought Information System, NIDIS, and the Southeast Regional Climate Center. You can register for these monthly webinars with the link that is shown on the screen. And if you have any additional comments or suggestions for future webinar topics, please let us know. You can contact me with my email address there. We always include a summary of recent and current conditions as well as future outlook, both for climate and water resources, as well as a key topic of interest to the region. So now we'll move forward to the question and answer period. Okay, great. And let me start with, well, first of all, we had a request to include the Tennessee River watershed that borders the Southeast in these monthly assessments. So we will definitely consider that. Thank you very much. We understand that our political boundaries are ignored by weather and climate. So thank you. Now we have a question regarding the Saharan Air Layer. So maybe I'll direct this one first to Sandra from the RCC, and then other panelists online can respond as well. The question is, the Saharan Air Layer, SAL, has been occurring all the time and has been affecting the air quality of the Caribbean and Florida? If so, I haven't heard much about it until recently. Is this because the recent one was particularly bad or noticeable?
Yeah, and that's a great question. As a matter of fact, the Saharan Air Layer does occur just about every year, but this one was particularly more impactful and more dusty, I guess. Puerto Rico tends to talk about the Saharan Air Layer a little bit more. They see it every year. It gets dusty inside their houses. But like I said, this one was more impactful. It was, really, really reduced the air quality for the Caribbean and Puerto Rico this time around.
Thank you, Sandra. Do any other panelists like to add to that? Okay. Our next question is for Chip regarding the wet bulb global tool. Let's see. Chip, you should be able to see these questions as well. Are those images of the WBGT observational? What data source are they from? Because it is very curious that the WBGT is higher in the morning. This seems strange.
Okay, that's a really good question. And when I first got these results, I had the same question myself in regards to the peak. And it turns out that there was a little bit of confusion there with the slides because I meant to put Eastern Daylight Time there. So what we're thinking of as the morning is really the late morning. It's going from 10 o'clock in the morning until 1 o'clock in the afternoon. So that's one thing to point out there. But I think that relates to the fact that by and large, over much of the Southeast, we see sunnier skies in the morning. So again, this is an average over the course of the summer. So it's sunnier, so we have more solar radiation that's coming in. Also, it's often the case that the dew point temperature, the measure moisture in the atmosphere is a little bit higher in the morning because it hasn't mixed out yet. And so you get evaporation of dew off the ground. But I tell you, the biggest factor is wind, that winds tend to blow faster in the afternoon. So again, a lack of wind, more solar radiation, and slightly more humid, all those coupled together skew wet bulb globe temperature more to the late morning and basically around the noontime hours. Now, in regards to data sets, we use gridded initialized model data there. I don't have time to go into the details of it. One thing is that we've been interrogating that data, comparing it with observations, and they actually compare pretty well because this is a data that's initialized that goes into a model, so they're using ground truth in the production of this data. So we think it's good data, but obviously there's some local details that are basically averaged out. So like any data set, it's far from perfect.
Thank you, Chip. And just a couple of more follow-on questions. Why is the new tool showing higher WBGT values in the afternoon?
Okay, so and I think this gets down to the details of it, that when we average it out, the highest values, as we were just discussing, happen in the late morning and right around noontime. But if we look at the greatest values that we see over the course of the season, so we take the day in which the values are the highest, indeed, those will be in the afternoon, because those will happen to be days where you don't get the convective clouds. You don't get all the cumulus clouds, you don't get the storms. And so temperatures, of course, continue to rise. And these might be days too in which there's big high pressure over the area, so there's not hardly any wind. And so anyway, when you subtract out the influence of clouds and thunderstorms and all that, then you're going to tend to see that maximum occurring more in the afternoon hours than the late morning hours.
Chip, here's another one related to the same topic. This is a good one. Can you work on a quote, real feel, unquote, or another term for the WBGT so that sports and outside workers can start using this tool?
Yeah, and that term is a mouthful there, and it took me a long time before I could say wet bulb globe temperature, without that. We need a better term for it, and this has been talked about. There's a lot of people that are using it. I'll mention that it's really important in occupational safety, and so there's guidelines in factories and so forth. So they have wet bulb globe temperatures in factory settings where there's a lot of dissipation of heat, and so they need to have adequate cooling, and so they're always measuring that. So, but it's a really good point and question. We need to really be getting it out there more to outdoor workers. But we really need to work on wordsmithing and coming up with means of clearly describing what it is, and how those values correspond to what you're doing. And so, for example, if you're out there and you're in a crop field, okay, and harvesting something, what does it mean when the level is red or yellow or whatever? And so anyway, we need to collaborate with people, and those are definitely, I think, great guidance going forward. Yeah.
Chip, there's also a couple of comments here saying thank you for sharing this. There's uncertainty on what wet bulb globe temperature was, and you explained it well, so thank you. This question for Sandra. Do you happen to know if Savannah saw its warmest first 6 months of the year on record? And if you don't know that offhand, we can certainly get that information and send it to the person asking.
Yeah, that's a great question. So far from what I can tell, it's tying for the fourth on record. It's not the warmest 6 months yet, but let me look further into that, and we can really dive into that a little bit more for you.
Okay, thank you. Another request to change the name of the wet bulb globe temperature tool. This next one is for Chip again. Let's see. Oh, a recommendation for called heat stress factor, the potential name. Also a recommendation in terms of the modeling to further ground truth in the mountains. It can get unbearable down in the valleys on hot summer days with no wind. So that was a comment.
Yeah, and so again, we need to work on the name for sure. And I think that's a great point about the mountains. Mountains are complicated, and when we're trying to model temperatures and humidity and wind speeds, and so we have to think of refining models to better get at that. Our tool does kind of show there that, well, I shouldn't say our tool is based on National Weather Service forecasts. And I think the National Weather Service does a good job of forecasting in valley locations. So I think our tool does a good job, but this is not revealed in the plots that I was showing you that showed generally much lower wet bulb globe temperatures in the mountains. And I'd like to, improving those climate maps I showed you, I'd like to figure out a way of getting those high values in there. And I'll just point out a place in West Virginia called Logan, which sits down in a very narrow valley. And we got weather observations from there, and we got a wet bulb globe temperature off of that. And I was astounded that they had a number of occasions of black flag conditions. And so it maybe sits at 1,400 feet elevation, and it's got, if you go up there, it's well over 2,000 feet. So, but anyway, these little nooks and crannies that you see up there, it can get really warm, and of course they're sheltered, and so there's very little wind. So anyway, I think that's a great point there to bring out.
Chip, I have two more questions on wet bulb globe temperature and then one question on drought. So we'll the heat stress tool. Can you please comment on the graph near the end that seemed to show the lowest nighttime temperatures at approximately 3 to 4 a.m., but not at 5 a.m. before first light? What time is coolest? And I can bring that up. Is it this one?
Yeah, and so I'm looking at, and this is interesting because all of my attention's been directed to where it's really warm, and honestly, I've never looked down there to where you see the minimum values observed there. But indeed, that's a very good observation, and you see that the lowest values are typically observed. It looks like here, and this is just the vagaries of the weather over the next couple of days for Fayetteville, the location pointed out. But I see, Tuesday, it looks like WBGT is lowest at 6 in the morning, and then it's maybe 5 in the morning on Wednesday and 4 in the morning on Thursday. The one thing is that we know that temperatures actually can get cooler slightly after the sun rises. So temperatures, there's a lag. It takes a while for temperatures to go up. The sun has to get high enough in the sky to bring in enough radiation to compensate for what's going out. But other things can change. And what I would guess is happening there is that basically wind speeds are decreasing, that maybe there's a little bit of wind and then there's no wind. Again, a lot of sensitivity around wind speed. So winds maybe could be playing a role in that. But of course, I'm just speculating. I will say here too that this is based off the National Weather Service forecast grids. So they're the ones that are showing this, and we put a lot of trust in that. They're the experts. But yeah, excellent question there. And it brings up a question too, is it ever dangerous in those hours? If you're, for whatever reason, wearing lots of clothing, that even though those values are well below the green there, it's just something to think about.
Hey, Chip, and last question for you regarding the tool. Would you use this data set to encourage an earlier or later football practice time? Wouldn't temperature factor in more than wind?
Wow, and that is a great question too. And I would say it's dependent upon location. Location always matters, right? And a lot of it's around shade. And when we went visiting these different practice fields across North Carolina, we were talking about getting into September where the sun's at a low angle in the sky. And so oftentimes they would have maybe some trees or buildings on one side. And if they delayed practice, say on a really hot afternoon, if they delayed an hour, then WBGT would be going down, but then they could take advantage of the shade going into the evening there. And I don't know, that might be the case in the morning as well, particularly getting into September, but just generally looking at WBGT, and talking with people is that some of them will have a practice early morning before it gets too hot. And then this is when they start practice in August, which is the worst. Late July and August is the worst time of the year. But basically an early morning practice or a practice that starts going really late afternoon and then goes into the evening there.
Okay, thank you, Chip. To the person who asked about Savannah, and we'll email this as well, the first 6 months of the year at Savannah is the third warmest on record. The data goes back to 1874. Thank you very much, Victor Murphy from the National Weather Service, for that answer. This question is related to early warning of drought. Noticing drier and hotter conditions taking hold in the northern half of Virginia, though just out of range of the Southeast river maps, what is the prospect for a flash drought developing? Would any of our panelists like to respond to that?
Chip, I'll go ahead and just take a stab at it and say that by definition, a flash drought can pop up quickly, and it depends on the nature of the drought. But when we talk about a flash drought, we talk about areas too that use a lot of water, so rapidly developing areas that are, that can drain their reservoirs quickly, through irrigation and so forth, and that. We look at some of the worst flash droughts in the past, it didn't really matter how wet it was before it happened, that these things popped up very quickly. For example, we had one last September in much of the South, and it got really bad. And prior to that, it wasn't especially, I don't recall that it was especially dry. So it was sort of regular moisture conditions, if not in some areas, maybe above normal moisture conditions.
Meredith?
Yep, go ahead.
Yeah, this is Victor. Reference the flash drought thing. It looks like the next 7 days or so, the Virginia area or Northern Virginia should see about a ½ inch to 1 inch of rainfall, which should pretty much keep things probably status quo since that's about near normal rainfall. But the week 2 period looks very, very wet. So based on that, I would think the drought should stabilize, or the recent dryness should stabilize this week and then improve next week.
Thank you, Victor. Chip, we have a couple of last edition questions regarding heat tool. To what extent has microclimate interventions been examined as mitigation or adaptations for improving wet bulb globe temperature?
Well, another good question, and a lot of this really is out of my realm. I know that there's been a lot of work done in urban areas, in terms of putting in more trees and so forth. One of the big effects, obviously, is direct solar radiation. The other thing too is that, and you can find, like in a desert and so forth, it can get really hot. But the drier the surface gets, and you find this in urban areas, it gets even hotter. And so making surfaces green and planting more things, you get a cooling effect. Now there's the slight trade-off that the humidity can go up a bit, but of course, with there being a lot more shade around, that makes a huge difference. But what we do is we really mitigate against the urban heat island, which can obviously make wet bulb globe temperatures higher than they would otherwise be.
Okay, Chip, in the essence of time, I'm going to take one more question regarding the wet bulb globe tool. And I also wanted to, regarding the flash drought, we have the CPC flash drought map does show a chance of flash drought in Virginia. Thank you very much, Pam Knox from University of Georgia, for showing that. But one of the purposes of doing these monthly webinars is exactly to have that early warning look ahead of where flash drought or drought will be rearing its head within the region. So we shall see. Last question. This is for Chip. Actually, first a statement and then a question. Number one, please consider changing the timestamps on WBGT to reflect actual working times. This could be a small but important fix for non-meteorologists. And the last question is, if wind channeling could keep and improve movement and result in lower impacts, wouldn't that adaptive strategy be beneficial?
Yeah, that's a great comment. If we can engineer an environment where there's more airflow. So I was emphasizing slight decreases or slight increases in wind speed can really reduce wet bulb globe temperature. The question, though, is the feasibility of doing it. And I talked to some athletic directors and trainers, and one of the questions we asked them is about fans, because you can buy these very large fans. And we had heard too of tennis practice, where they bring a couple of fans onto the sides of the tennis court, and they could circulate the air, and it would make it somewhat cooler. But apparently, in a lot of cases, they don't have electricity out where the fields are. You would need an incredibly long extension cord to make that work. And they're basically saying they didn't think it was feasible. Not to mention that a lot of these high schools don't have much of a budget, for these technological solutions.
Great, thank you, Chip. And with that, I'd like to thank our excellent speakers one more time. Jeff from the Southeast River Forecast Center, and Chip and Sandra from the Southeast Regional Climate Center. Again, we will be sending out by tomorrow a summary of this presentation, as well as a link to the webinar recording on YouTube. Please feel free to share. If you need a copy of the slides, you can contact me directly at meredith.f.muth@noaa.gov, and that will also be in the email. And I think with that, I'd just like to wish all of you a wonderful day, and we hope you can join us for next month's webinar. Thank you very much.